Howdy! Here is 5-6, contraction of a skeletal muscle. So starting out with some basics, we have, pick a color I like, there we go, that'll work. We have, when we contract a muscle, we usually use it to lift things, to move our body and so on. And so when a muscle contracts, we call the force that the muscle can apply onto something the muscle tension. So when I pick up my phone, I'm exerting a force on the phone. So that's called my muscle tension. But my phone is also exerting a force downwards due to gravity and the weight of the phone, which is called the load. So we have muscle tension and load. They're kind of like opposite to each other. So if the load is pulling downwards, then the tension is pulling upwards. So they're like opposite forces. Okay. Now, when contractions cause the object to not move, like if I'm holding that weight there and I'm holding it straight out and until my hands start shaking, we call that an isometric contraction. So it doesn't move the weight. And so you see a lot of exercise places, they do isometric exercises that if they don't want to get too big and bulky, usually guys like to do where they lift big weights and they get all huge and everything, but girls usually like to do isometric because it just kind of gives tone to the muscles as opposed to making them all big and beefy. So when a contraction does not move the weight, then we call that something isometric, like pushing on a wall, pushing on your desk, whatever. But if it's isotonic, then I have the ability to go beyond the force of the load and actually move it. So they're showing two pictures down here of an isotonic where I do get to move it, and then isometric where it does not. I don't know what he's holding there. It looks like a fence and looks like he moved it to me, but anyway. Okay, so how a muscle contracts depends completely on the motor neuron, that guy right there, and how it branches out into the muscle. So this is one little fascicle, one little bundle right there, and inside are the muscle fibers, and inside of the fibers are the myofibrils inside of there like that. And as you can see that each of the fibers has a couple of these little things on it. Usually it ends up being one per fiber, but they got a little crazy with the picture there. So each muscle in your body gets at least one motor nerve, and a nerve contains hundreds to thousands of axons inside of it. And when that nerve gets inside of the muscle, it branches out to all the different fascicles and all the different fibers in there. And so where the neuron itself spreads out, we call that a motor unit. So a motor unit is just a motor neuron and all the muscle fibers that it supplies. So big motor units can usually be found in big muscles like your thigh, your back. Small motor units are things that require very fine detailed movement we would find in like your fingers and eyes. Now the motor neuron, as it spreads out, doesn't only attack one fascicle, but actually spreads out and attacks many fibers within many fascicles. So that way, when I stimulate this muscle, not just this fascicle will contract, but several fascicles will contract at the same time. Okay, so how does a muscle work? Well, usually you think about it, you send an impulse down to your muscle, and then the muscle responds by contracting. Well, that sounds pretty simple, and it is. We call that a muscle twitch. It's just a simple move. There it goes, it moves. But it's not as simple as that. So how do I know what a muscle does? Well, I can use a myogram to determine how my muscle reacts. So over here is the tension, which is the amount of stress applied to the muscle, and then we have time in milliseconds down here. Remember, milli means 1,000, so that's supposed to be 1,000. So 1,000 milliseconds equals 1 second. And here it only goes up to 100, so that's 1/10 of a second. Okay, so a muscle twitch is just when I apply a stimulated force to my muscle, it's going to increase in tension and then eventually decrease back down to zero. All this within 1/10 of a second. And we always notice that this happens in three distinct phases. The first phase is called the latent period, which is from the stimulation to where nothing really happens. I don't see anything happening, but the calcium is getting ready to explode out. So this is what takes, as you can see from the time there, it only takes a few milliseconds, but that's for the brain thought to travel down the nerve, down into the muscle, and then down into the fibers itself. So it takes a few milliseconds for that to happen. The tension begins to increase, but there's nothing shows up on the myogram. So we need to wait for we hit the period of contraction, and that's when the calcium is let out and it goes in, and the actin and myosin are able to attach to each other and start the little crawling process. And so that's what's going on from here, to the top of the peak there. That's when the most tension will form inside of the muscle. And then we have the last one, the period of relaxation, which is when the calcium is done, it goes back into the sarcoplasmic reticulum, and the muscle can't contract anymore. And so then the muscle relaxes back down to its original state. So every muscle twitch has those 3 stages. Excuse me. But most muscles don't just do a single twitch and they're done. They do lots of other things. So we call those lots of other things graded muscle responses. Smooth muscle contractions that vary in strength. And I'm not talking smooth muscles, but a muscle contraction that is smooth, if that makes sense. Okay, so there's a couple of different ways I can mess with how your muscle contracts. One, I can change how often I stimulate it, and I can change how strong I stimulate it. And then we can get lots of different reactions like down here. So let's take a look at the first one. If I change the frequency, so pretend that me poking you is a stimulation. So if I just keep on poking you like this over and over and over again, what's going to happen is that those identical stimuli will cause an increase in each successive twitch. So here's a twitch, here's a twitch, here's a twitch. But the only thing is I'm not letting it get back down to the bottom. And so if I poke it and apply the stress to it, then it's going to twitch again, but a little bit higher than the previous. We call that thing a wave summation. It occurs because the first twitch didn't fully relax before the muscle could relax. So if a stimulus occurs before repolarization, though, no summation occurs. And then it just ends up going all the way back down, all the way back down, like that. Okay. Unfused tetanus, which is this one right here, is what happens. It's kind of like a wave summation, where instead of, there's a little less time in between. And so instead of, up, down, since the timing, because we can't see how many seconds are here, the timing is so close together, it looks more, my pen isn't letting me do it, but it's much closer together, and so your muscle just kind of quivers and twitches. And then we have the last one, which is fused tetanus, which is where the poking is so constant, it feels like they're just constantly pushing you. And so the twitch, it doesn't have any time to relax whatsoever. The muscle can't relax, and so you just end up getting a continuous tension on the muscle alone. Okay, second thing I could change, there goes light, excuse me. Hello. Come on, light, find me. Thank you. All right, sorry about that. Okay, second thing I can do is change the strength of the poke or the action potential. And so the first thing we have is something called a multiple motor summation. So what happens is instead of one neuron reaching out and getting the muscle fiber, I get lots of neurons reaching lots of fibers, and then therefore I can control my movements more precisely. So just like if I zap you with that little machine, your hand just goes like that. But if I tell which ones to do their thing, then I can control much more precisely how my muscles work. So recruitment is kind of how that works. If I deliver shocks of increasing voltage to the muscle, then that's going to call more and more fibers into play. If I just do one shock, only a couple of fibers are going to respond. But the more shocks I give, and the higher strength that I give the shocks, then the more and more fibers are going to want to contract as well. So I keep on shocking until I hit the threshold stimulus, which is the amount of voltage that is required in order to see an actual contraction. So, I could zap you and nothing happens, but there comes a point where you finally start twitching, and that would be the threshold stimulus. And then I can increase the voltage by, just crank it up, but there's going to come a point where you can't do anything else. That's called the maximal stimulus. So I can't contract anymore. That is as strong as my body can handle. Now, if I increase the voltage on here, so say, each arrow represents a higher voltage. So I'm going to draw the arrows a little bit bigger, so that way it's kind of more visually showing that. What's going to end up happening is I can make something called trip. And trip is a staircase effect. It's a pattern that is caused by the increasing strength of the muscle contraction. Now what's different here between the wave summation and this one is that notice that they get to go all the way down to the bottom in between. So that's what makes this one different from the other. Now muscle tone, when you have your arm just sitting there doing nothing, it still takes the shape of the muscles of your arm, because even though you're resting and relaxing, your muscles are still contracted, and they're, well, slightly contracted, and that is what gives your muscles their particular shape. So we just call that muscle tone. Now, if you can't see the muscles, and you're kind of flabby around there, well, then you don't have as much a muscle tone. So of the two types of exercises or contractions that we can do, we can see that the best way to make these work, well, we have isotonic, and that should be red right there. I don't know why it's not. So an make it red for you so it actually stands out. There you go. Okay, so we have an isotonic contraction, and there's two different types. If I pull up on a weight and my muscle shortens, then I call that a concentric contraction. But if the weight is causing the muscle to get longer, I call it an eccentric contraction. But if I just hold the weight out and there's no lengthening or shortening of the muscle, then I just call that an isometric contraction. So I've got a little picture here to show you that right there. So here's isometric. My muscle's not moving. I'm just holding the weight out, so there's no movement whatsoever. But if I bring it closer to me and the muscle gets shortened, that's a concentric muscle contraction.
Krista Jones, please call extension 11030. Krista Jones, please call extension 11030.
Okay, and if I move the force away from me, then my muscle strengthens or lengthens, and then so I would call that an eccentric contraction. Okay, that's where we're going to stop. So you guys have all the notes now up until where we are, and where's the stop button? There it is. Okay, see you guys tomorrow. Bye. Still going? Yeah, still going. Okay, let me try that again. Bye.